Yes, guys. So here you can see have a hello world program here. So, and basically here you can see std cout and hello world \n, which has been written here. And sometimes people will get confused. So whether should I need to use std endl or I need to use a \n. So what is the difference between these two things? And we will see practically what is exactly the meaning of this std endl and when we need to use this std endl and when we need to use a \n. So for that one, so what exactly we will do is, so once after this experiment is done, so I tell you what is the exact difference between stdndl and \n. So for this one, so what I'll do is, so first I'll go and compile this one. So I'll say g++ test.cpp and let me increase the font little bit. Then I'll say a.out. So everything is working fine, right? Now I'll go back to my program. So then what I'll do is, so instead of writing this one to a console, let me write to some file. So I'll say fstream. So then what I'll do is I'll just remove this one. I'll just open a file, output file stream. So let's say output file stream OFF. So let me make this one as a data.log and let me open this one in a append mode. So that like every time, so whenever the file is already exists, so it will open in an append mode. Then what we have to check output file stream. So is it really open? Yes, if it is open, then I'll go ahead and once everything is done, so I'll be closing this. So this is what a high level code. Then what I'll do is I'll create a while of one. Now, instead of writing to std cout, I'll be writing to this output stream. So which is nothing but my data.log. So I'll say hello world. So let me say \n. So if I do like this, so then what will happen? So continuously it will keep on bombard and it will keep on write a lot of data into this one, right? So that's why let's sleep for some millisecond or something like that. So I'll include thread here. I'll say std this thread and I'll say sleep for std chrono. I'll say milliseconds. Let's assume 100 milliseconds. I'm sleeping for 100 milliseconds. Okay. So let me decrease the font a little bit. So I'm sleeping for 100 milliseconds. Then I'm writing a hello world with a \n. Here can you see I'm using a \n. Now we will see what exactly it will happen. I'll go back to my terminal. I'll say g++ test.cpp execute a.out. Now my a.out is running. Then I'll go here and I'll open data.log. Can you see? So nothing is getting printed here. So not at all getting any data, right? So what exactly is happening behind the scene? So for that one, what I'll do is, so let me close this one and I'll say Control-C. Then I'll delete this data.log. So instead of this one, so now I will do std endl. Now let us see what exactly the difference between these two. I'll compile, execute a.out. So it is running. Now I'll open data.log. Can you see how this hello world is keep on writing? But why whenever I use this \n, why it is not getting printed there? That is what exactly the confusion, right? So what exactly this std_endl is doing is, so basically, so it is putting \n, then in the next line, it is doing something like a flush. This two job is done directly from this std_endl. Now, if that is true, what we have to get is, so let me remove this data.log, compile this one, execute a.out. If that is true, if I open this data log, can you see? So I put a \n, but on top of that one, I am putting a flush command. So what exactly this flush command is doing? So in order to understand that one, so what exactly we need to do is, so let me play something with the \n. So whenever I use this \n, what happens is, so I'm not explicitly writing to the file, rather than this all this data is going and storing in my user buffer. So once it reaches either 4 KB or 8 KB, depends on the configuration of the OS. So it will directly take all this chunk of data at one shot and it will write to a file. So why exactly it is doing so? Because every time whenever you are trying to write this data into a file, what happens is internally it will make a write call. So that is a system call. So whenever you do a system call, then there is a context switch is happening. So then basically what happens is the context switch from the user space, it will switch to a kernel space or a kernel mode. and it is an expensive operation and it will take little bit of time. So that is where the performance will get hurt whenever you are using a flush, or which is nothing but a STD endl. Now, in order to prove that one, so whenever it is reaching some let's say 8 KB or 4 KB, so let us decrease this time little bit. Then the same thing I'll use \n. Now I'll go here, compile it. So let me remove data.log, execute data.out. Now I'll open this data.log. Let's wait for some time. Is it really true or not? So I'm waiting for some time. Yeah. Can you see here? So almost at one shot data has been written, 631 line. Again, can you see? At one shot some data has been written. Let's wait for some time. 1262 is a line number. Can you see? At one shot data is written. So that means it is waiting for this buffer to fill. Once the buffer is filled, at one shot it is writing into a file. So this is like a little bit optimization which is being done. So that's why you should avoid using a STD endl. Now again, let me prove that one, how exactly this thing is happening behind the scene. So now what I'll do is, so I'll say remove data.log. Then let me analyze the system APIs using strace a.out. So I have to execute this one, a.out, enter. Can you see? It is still sleeping. So nothing has been written. So let's wait for the buffer to fill. Yeah. Can you see somewhere in between? So let me decrease the font little bit. So let me wait for some time. So it is keep on sleeping, but it is not writing anything to a file. So now let's wait for some more time. Yeah. Can you see here somewhere? So there is a write v is happening. So for the file descriptor 3. So the hello world \n. Can you see so many number of bytes? So almost like 8190, almost 8 KB. 8 KB of a data has been flushed at one time, at one shot. So that is where it is being optimized. So that is where in between here you can see there are only whenever the 8 KB is full, so it is directly writing into a buffer. Now the moment I change this one to endl, let's see what happens. I'll say std endl, I did a std endl. I'll say remove this data and g++, compile this one. I'll say strace a.out, enter. Can you see how many times? Every time whenever there is a endl, so it is keep on writing. So hello world. So can you see? It is writing into 3. At that time, if you see, it was using write v. So whenever I say what is this write v, so basically it is saying from the IO buffer directly it is writing using write v command, write v system API. But in the case of std endl, every time it is using a write API, the context switch is keep on happening. So from the user space to kernel space. So that's why the performance hurts. So the moral of the story is, so if you want to get the data as soon as possible into your data.log file, then use a flush or nothing but a std endl. Otherwise, I recommend to use \n so that it will be optimized and your executable also performs well. That is the meaning of this one. Yes, guys. So basically, this is the difference between std endl and \n.